Hello and welcome to another Java tutorial. In this tutorial, I'm going to discuss a very important and interesting topic, which is how to code in Java, how to write Java programs in a very nice interactive mode. And we already know that the Python programmers are always very proud of their Jupyter notebooks. If you go to jupyter.org, you see that the Jupyter notebook pretty much revolutionized the way you code in Python. And then the question is, can we take advantage of these Jupyter notebooks to do Java programming? And the answer is yes. And especially if you're trying to learn Java or just do some exploration, Jupyter notebooks are just definitely the way to go. I mean, I'm personally an Eclipse guy, right? So I love Eclipse. I think it's the best IDE. But then if you sometimes want to teach Java programming to others, the fact that Jupyter notebooks can give you instance feedback, and then you can also add notes in a very nice way using Markdown language. I think it's the best way. It's always good to have these Jupyter notebooks around. And so basically Jupyter Notebook is just a front end. It doesn't do any compilation. It doesn't do anything. So whatever you write in Jupyter Notebook is considered a text. It's converted to a JSON file, which is just a pure text, right? And then what happens here is that this is sent to a kernel, and the kernel could be for example, here is Python 3. And then the kernel is where the execution of your commands happen, right? So it's that means the kernel has to be some sort of server which is already alive, and then Jupyter Notebook can interact with it, send command to it, and the server can interpret those commands, execute them, and send the results back, right? So the Jupyter Notebook doesn't do anything. It's just a GUI that transfers your code, your writings into JSON formats, and then it sends it to a server, which is the kernel that is specified, and the kernel executes that, and then it sends the result back to the Jupyter as a JSON file, and then Jupyter knows how to render that JSON file in a text format or image. And the fact that Jupyter notebooks can very nicely render images, it's always a very nice thing to have, right? So whenever I try to play with the image libraries in Java, I always try to use Jupyter Notebook, because it gives you instance feedback. And I will show you an example of how to manipulate images in Java inside the Jupyter Notebook. So I said that Jupyter Notebook doesn't have any execution, right? So we have to, if we want to do Java programming, we have to do have a Java kernel, right? So before that, in terms of installing, it's very easy. If I open up, for example, I already have launched a Jupyter Notebook. But then if I open a fresh terminal here, I use, first of all, you have to install Python, right? So I recommend you use Anaconda. So if I check which Python I'm using Anaconda 3 to manage all my Python stuff. And then if I see which Jupyter is on my path, you see that it's from Anaconda 3, right? So when I launch Jupyter from Anaconda 3, it already knows that it has to use Python from Anaconda 3. So if I launch it by default, it uses the Python kernel, Python 3 kernel. So if you want to launch a new Jupyter notebook, all you have to do, you have to make sure that Jupyter is on your path, and then you say notebook. And from whatever directory you're launching it creates an untitled notebook in that directory, right? I have already launched the Jupyter notebook, and once you do this, what it does, it creates a server that listens to your stuff, right? So it's a server and it opens up this tree. And then what you can do, you can create a new notebook, and then you can select your kernel, Java, Python 3. You can also install other kernels. Here by default it comes with Python 3. I have also installed Java kernel, and if you want to install Java kernel, there's this GitHub repository from Spacer Park, which is called IJava. And the reason it's called IJava is that Jupyter Notebook came from a Python project which was called IPython. So we know that Python, you can launch Python in an interpret mode in your command line. For example, you can say a equals 2 plus 3, and a5, you can say 5 plus 10, etc. Right? So this is a Python live interpreter, and obviously you can exit it. But then IPython I guess I don't have it right now, but I can launch it with the Anaconda 3. It's not on my path. IPython was an enhanced version of this terminal interface, and then from that the Jupyter Notebook project came out, which really transformed the interfacing or writing nice interactive code with Python, right? So what do we need? We need a Java kernel for a Jupyter Notebook, and all you need to do, you need to basically go to this IJava GitHub repository, and then go to releases and download the IJava 1.30 zip, right? You download it, it's a zip, you unzip it, and then you can basically and then when you unzip it, it creates a IJava directory. Let me see if I it creates all right, so let me go back to the Git. Let's search for IJava, and then you go there, and then let me open up Finder window. Let's go to downloads. I have it, I downloaded it, unzipped it. I have already unzipped it. So IJava 1.3, and as you can see, it's just one jar file, which is going to be your kernel, or basically it handles it launches a server and then handles the interaction with the JSON that it receives. And then you need to run this install py. It's a Python, so you run it with Python. It copies this kernel at somewhere that Jupyter Notebook can find it. And then after that, when you launch your Jupyter Notebook, it can basically also it can offer this Java kernel. So it's very easy. You don't need to really do anything, right? So you just download this IJava, unzip it, and then run this install.py with a Python interpreter. All right. So you run this with this install.py with Python. It already copies this jar somewhere else and handles the kernel. If you look at this kernel configuration, they are in the java -jar and then install directory. So it launches this jar file, and this jar file initiates a Java server that can execute. And how does it work? It works based on the JShell. So JShell was introduced from Java 9, and it's an interactive mode, very similar to how we launch Python, right? So Python, it goes into the interactive mode, and then we can exit it. Now if I see if JShell is available on my path, as you can see, it's available. I'm using JDK 15, and I can go into the interactive mode with JShell, right? So basically that jar file from IJava, it launches a JShell behind the scenes, and it interprets the JSON file that Jupyter Notebook sends, and then it knows what commands to execute. JShell executes the command, and that jar file sends the result back to Jupyter Notebook as a JSON file, and then Jupyter Notebook knows how to interpret it. All right. So we can directly play with JShell. I can say define an int variable a2 plus 3 and a5. I have accessed it, a times a 25, and if I want to exit it, I have to use a environment command, exit /exit, and now I'm back to the terminal, right? So again, Jupyter Notebook is very handy in terms of really getting immediate feedback in terms of programming, right? Sometimes you don't want to launch your Eclipse IDE or whatever IDE you're using to just play with some library or something. So it's very easy and nicer to work with Jupyter Notebooks. And one of the main things that I love about Jupyter Notebook is that it gives you instant feedback when you're playing with graphics, right? If you're trying to plot a chart or play or manipulate an image or something, it can render the images. And that's a very nice thing about Jupyter Notebooks. All right, so you download the IJava, and then you run this Python file, and it moves this jar file to somewhere that the Jupyter Notebook can find it. And now after that, when you launch the Jupyter Notebook, you have the Java kernel available. And so as you can see, if you are not familiar with Jupyter Notebook, I'm going to give you a brief tour here. And Jupyter Notebooks are very powerful. They have the idea of cells, and a cell is any one of these that has an in or out number. So you can have input cell, and then if you want to execute a cell, you run it, right? or you can go cell and then run cells. If you have multiple cells, you want to run all of them, run all above cell type. And then we have different cell types. For example, if you want to write markdown, you can select the cell to be markdown and say you can write markdown, and then after you execute the cells, Jupyter Notebook converts it to a very nice format. So welcome to Jupyter Notebook with Java. And then you can run this, and the handy shortcut is Shift Enter. So I personally always use Shift Enter. And then if you run multiple cells, if you run a cell with Shift Enter, it creates another cell. Sometimes I just want to quickly create multiple cells, right? So by default, when you create a cell, the type is code, which means now I can use my Java kernel. And let's say I want to I want to calculate the sign of some number, right? So let's say double A equals math.py math, and then first of all, we don't need to import the math library, math object, because it's by default imported in Java. And in Jupyter Notebook, we have a tab completion. So if I hit dot and then press tab, it tells me all the methods or all the fields of math that are available. So math.py times 0.25. So pi over 4, right? And then press Shift Enter, it executes the cell. Now this variable A is available in the memory. So any other cell, if I say A and Shift Enter, it calls the toString method on it. And so you don't need, one of the good thing about Jupyter Notebook is you don't need to say system.out.println A. Whenever you have a raw element here and it's just itself without any equal sign or anything, you execute that cell, it just calls the toString and tries to convert this variable to a string, right? So that's one thing, that when you execute this, and obviously it's better to terminate with semicolon. If we have multiple lines, double B equals 2.3. If I execute, this works fine. So the last line doesn't have to be terminated. But if the previous line doesn't terminate, then when Jupyter sends this to JShell gets confused, because you have to terminate with semicolon so that Java knows that these are separate commands, right? So now A and B are available. Obviously, we can say A, and then we can say B, and this. And if you want to delete a cell, you can select the entire thing, which is blue, right? So so when you click on the cell, inside the cell, you're in the type mode, so it's green. But if you select somewhere else, it becomes blue. And now, for example, you can edit and you can delete this cell. I normally use the shortcut, which is you make it in the green mode, in the blue mode, in the selection mode, and press D twice. So press D twice, right? All right. So and then I can say math.sign, and again I can say dot and you press tab to look at the autocomplete, and then sign, and then A, and then sign of pi over 4 is 0.707, which is 1 over math.sqrt2, right? And then so this is how you get instance feedback, which is very nice. And then so this is one thing about the Jupyter Notebook, right? And then obviously you can import libraries and from Java or from other jar files. I'll show you maybe in the future lectures how to import. I personally prefer, when I use Jupyter Notebook with Java, I always prefer to manage my dependencies with Maven, because if you have a jar file that also has dependency on other files, it gets complicated, but Maven automatically handles that. And then if you look through this, basically look through the guide that is in the GitHub. Obviously, requirements that you need to JDK 9 or greater than 9, because it relies on JShell, and JShell only came from JDK 9. And then So I mentioned that for installing, you just download the IJava zip file, unzip it, and then run that install py, and it automatically copies, and then everything works fine. And then with Maven, you can also basically, and again in the kernel JSON file, you can configure your Java, you can enable or disable the assertion, you can tell it how much memory to use, etc. And I believe there is something about Maven here that you can manage your dependencies, but before that you can also look at the documentation. So if you select a function or a class and use the shortcut Shift Tab, it brings up the documentation for that object or method. So if I select math and then Shift Tab, it says it's Java lang math. The class math contains methods for performing basic numeric operations such as the elementary, exponential, logarithm, etc. If I click on the sign method and press Shift Tab, and it says double, it returns a double, takes the double method sign, returns the trigonometric sign of an angle. Special cases, if the argument is nan or an infinity, then result is nan. And then what you can do, you can also stick it to the bottom, and therefore the documentation is always in front of you regardless of how many cells you're creating. Sometimes you want to make sure that the documentation is in front of you, right? And the other good thing here is that if you have overloaded methods in the documentation, it shows all the versions of that overloaded method. For example, let's say I create a string builder, SB new string builder, right? All right, so, and then if I click on the constructor and hit Shift Tab and then stick it to the bottom, it shows me the documentation for all the overloaded versions of the constructor. So string builder doesn't take any arguments. It means that by default the capacity is 16 character. I can specify int capacity. I can specify initial a string. I can specify a char sequence. Note that a string implements the char sequence, right? So these are all the variants of this constructor. So sometimes, again, if you're learning a Java library, it's very nice to work with Jupyter Notebook, look at the documentations, and learn how to work with different overloaded methods or constructors. Now, obviously, I can say sb dot and then tab append and then hello world. All right, and then append space, this is a test in Jupyter Notebook, and then semicolon, right? And as you can see, because each one of these appends returns a reference to SB, and when you have a variable SB and you execute it, by default Jupyter Notebook calls the toString method on it, so it gives you instance feedback. All right. So another interesting thing that I want to show you here is a graphical feedback. So it's very nice. So Jupyter for Java image manipulation. Again, it's very nice to have feedback. So I'm going to create file, my image, and new file. I have a file on my desktop, so user, let's see if I can use a desktop, and then I believe it's called eclipse.jpg, my image. I hope this works, otherwise I can go to my desktop and grab this, right? So and then I can also, maybe let's put a cell on top of this. Okay, move this down, and then I'm going to put a create a new cell. So import java.awt basically I want to write import java.awt dot everything, I guess, and import java awt image dot everything, and import import Java AWT color everything, right? And then let's see if I can create a buffered image, image new buffered image, and then all right, so this going to, let's look at the constructor of the buffered image. So int width, int height, int image type. So you can create a raw buffered image, or you can let's specify a buffer image that doesn't have any data. Let's say 400 and 200 height, and image type. From color we have color space dot RGB. Let's see what options we have in this enum. sRGB, gray, linear RGB, and type RGB. And then let's see, so it just by default everything 0, every color is 0, and then that means that it's black. And as you can see, the Jupyter Notebook can render it very nicely. And then I can set a pixel, let's say image.set RGB. And if I look at the documentation for this method, set RGB takes a coordinate and an int number RGB. All right, so you don't set the transparency. So let's say in the middle, 200, this is the X, Y 100, and I want to set the pixel to red. So I'm going to specify hex 0, 0, the transparency is ignored, and then R, which is FF, and then green 0, 0, and blue, which is 0, 0, right? And then let's render the image again. And as you can see, there is a red dot here. You see this pixel now is turned red, right? And so again, I love Jupyter Notebook for this kind of manipulation because it gives you instant feedback on the graphics, which is very nice. Now I can create a buffered image. Image 2 is from image IO. Image IO. Where is this image IO? It's inside the image IO JavaX package. So let's go ahead and import it too. So import javax.image IO everything. And then let's create a, we can also use var because from Java 9 I'm using JDK 15, so var is also supported. Image 2 is new, or from image IO dot read. And then let's look at the documentation of the read method. Throws exception, returns a buffered image as a result of decoding a supplied. So it has many constructions. One of the constructors, one of them takes a file. So let's see if I can use this my image, and can't read the file. So I guess I need to set the path correctly. So let's copy this, and then let's move a cell above this. Let's see. Let's see if this works. Now, so okay, I had to specify the absolute path. And by the way, I launched this Jupyter Notebook from my desktop, so I believe just setting the relative path should also work. No, it doesn't work. Why? All right, let's specify the absolute path. And now if I ask it to render this image, it can render it very nicely, as you can see. And then I can also call the toString method on this image, image to toString. So again, if so you see when I render this image, it doesn't call the toString method. It actually knows that this is an image and it can render it, which is very, very nice feature, right? But if I call the toString, it tells me all the information, the width and the height. Obviously, I can also say image to get width 820, image to get height, right? 87. And let's say I want to draw a line, a red line, and try to manipulate this image. So I can say for int I equals 0, I less than 400, or let's say I from minus 200, I less than or equal to 100, I plus plus. So what I'm going to do, I'm going to say image2. Remember, buffered image, you can manipulate it. Set RGB, and this RGB takes an X and Y. So 400 plus I, 400 plus I. So I want to create linearly draw some pixels in a red color, and then the color is 0, 0, no transparency, or it doesn't matter. Red, which is FF, green 0, 0, and blue 0, 0. Alright, now if I draw the image again, as you can see, there is a line here, and these lines are single pixels, right? So you can see the single pixels that we draw. So again, Jupyter Notebook is very nice for drawing because it knows how to render images. So if you want to import an image, you can use the buffered image, and then from image IO you can manipulate it, and then eventually you can save it to a file again. So this was a brief introduction to Jupyter Notebook. In the next lecture, I'll show you how to use Maven to manage your dependencies when you're working with Jupyter Notebooks and Java. So please stay tuned, and I'll see you in the next one.